Good afternoon. Thank you for joining us again. My name is Mark Stewart. I'm the Director of RSK's Geosciences business, and I welcome you again to our latest Down to Earth webinar, which today is being given by my colleague Helen Macmillan, who's going to talk to us about the impacts of climate change on land contamination assessments. First, I'd like to go through our housekeeping slide with you all. So all attendees' microphones are automatically muted. During the presentation, you can post questions and we'll have a Q&A at the end of the presentation. As many questions as possible will be answered, but if we can't, then we'll try and get back to you individually afterwards. Shortly after the webinar, you'll receive a link to a short survey. If you could take a few minutes to fill this in for us, it would be very much appreciated. So without further ado, I'd like to introduce Helen Macmillan. Helen is an Associate Director and of our QRA group within RSK Geosciences. She has 20 years experience working in environmental consultancy and is a chartered geologist and a SOBRA for the water environment. She's also currently leading the SOBRA subgroup assigned to look at climate change considerations within controlled water risk assessments. So it's very well placed to deliver this afternoon's presentation. So without further ado, I'll hand over to Helen.
Thank you, Mark, and welcome everyone, and thank you for joining me in this afternoon's presentation on considering climate change in land contamination risk assessments. So I am going to switch my camera off while I go through the slides. I'll put it back on for question and answers, but I'll just switch it off for the time being. And this next slide basically just gives you a bit of an overview of what I'm going to talk about. So I think everyone is aware that our climate is changing, and this presentation will look at the implications this has for land contamination risk assessments that we complete. Initially, I'm going to provide a bit of background by setting the scene around climate change and what is projected for the UK. I'll then go over current legislation, policy and guidance relating to climate change and land contamination. We'll then look at CSM considerations associated with climate change and what implications this may have for the site investigations we design. Then summarise and conclude, and at the end I'll be happy to answer any questions that you may have. So we know the UK climate is changing. You just have to look at the news to see various weather-related stories hitting the headlines. So the picture on the top left shows intense rainfall that was experienced last July in Edinburgh, where half of the rainfall for that month fell within an hour, resulting in kind of quite significant flooding events. Conversely, we've got the picture in the bottom left. This was for the same month, and during that month there had been a sustained hot and dry weather period experienced throughout Scotland. And there were reports over drought fears, with Scottish Water urging customers to help conserve supplies after some reservoirs dropped to their lowest levels in 18 years. Hot, dry weather can also lead to increased occurrences of wildfires, and there's also been news stories relating to coastal erosion, which is another consequence of climate change. So what is climate change? Basically, the Met Office define it as the large-scale, long-term shift in average weather patterns and average temperature, and it's assessed by averaging data over a 30-year period, with the most recent reference period being 1991 to 2020. The State of the UK Climate 2020 report contains a number of statistics and trends associated with the climate in the UK, some of which you can see in this attached graphic. The key point really to note is that the UK climate is changing. Recent decades have been warmer, wetter and sunnier than the 20th century, and climate change is likely to result in more intense or extreme weather and significant weather events with a higher likelihood of heat waves, flash floods and drought. So what about future UK climate projections? How do we know what's going to happen in the future? So I'm going to take you down a little bit of a climate change science rabbit hole here. It is complicated and I'm certainly not an expert in it, but I'm going to do my best to explain some various concepts, because I think you kind of need to have a little bit of the background to it before we can understand how we apply that in the risk assessments we do. So future global climate change has been numerically modelled by the Intergovernmental Panel on Climate Change to the year 2100. And this is based on potential anthropogenic greenhouse gas emission scenarios. And these projections are based on driving forces of climate change, including physical processes in our systems, physical, ecological, and socio-economic impacts, and potential responses and adaptation to climate change by way of technology, energy, and land use. There is a rapid turnover of climate change publications within academia and from other regulatory and guidance bodies, and these scenarios have changed over time from the SRES, which is a special report on emission scenarios, which were published in 2001, to representative concentration pathways, published in 2014, and then most recently last year, shared socio-economic pathways were published. They're just various different ways of how you look at how the global greenhouse emission standards can be modelled. The modelling output results in projections, which the Met Office has used to determine the potential impacts of climate change for the UK. UK CP18 is the most up-to-date set of climate projections for the UK, and these are based on the RCP greenhouse gas emission scenarios. So they are likely to be updated in the future with the more recently published SSP scenarios. In general, UK CP18 projects a greater chance of hotter, drier summers and milder, wetter winters, along with an increase in the frequency and intensity of extreme weather. So the graphs below just basically show the RCP scenarios and projections for warming. So also RCP scenarios project warming. RCP 8.5 is the most extreme scenario, and it assumes that the world does nothing to combat greenhouse gases, with global temperatures changing by 4.3 degrees. Other scenarios also project warming, but to a much lower level, with RCP 2.6 being the most optimistic, and that projects a 1.6 degree warming. One thing to note, and this is shown in this graph over here on the right, is for RCP 4.5 and 2.6 to be achieved, then there has to be a reduction in CO2 emissions. So failure of the Paris Agreement is non-negotiable for these scenarios. Furthermore, for RCP 2.6 to be achieved, you have to go beyond net zero. So again, those are just things to provide a little bit of background. But really the key points to note are that climate projections only go up to 2100. RCP 8.5 is the most comprehensive data set, and also that the data sets are continually evolving. They're not set in stone, they aren't static, they are continually updated with the latest science. So these next slides are just going to show projected future climate change effects and influences across the UK, primarily using the UK CP18 dataset, and this is for the period 2061 to 2080. So in terms of temperature, all areas of the UK are projected to experience warming, with warming greater in the summer than the winter. And the figure shows that southern England is projected to warm more than northern regions in the UK. In terms of precipitation, rainfall patterns across the UK, they're not uniform and they vary on seasonal and regional scales, and will continue to do so in the future. Average rainfall is expected to increase in the winter months, but reduce in the summer. However, there is an exception to this in northeast Scotland, which you can see here, where a reduction in winter precipitation is projected. So winter precipitation is considered most important for sustaining recharge to aquifers. So SEPA are concerned that there may be a potential for drought conditions in this area in the future because they're just not getting that winter recharge. This slide here is just showing screenshots taken from the recently launched eFlag portal, and this shows projected variations in recharge, and again highlights differences across the UK, and shows generally the same picture as we've just seen before in terms of the precipitation patterns. Another thing to think about is sea level rise. Sea levels are rising, and that's due to melting polar ice and thermal expansion of the oceans, which is a consequence of climate change. Again, the pattern of sea level rise isn't uniform across the UK, and that's partly down to the effects of isostatic rebound. We've got sea level rises projected to be less in the north and more in the south. So we've spoken about climate change and what it means potentially for the UK in the future. Now going to go through basically just sort of setting the scene in terms of the UK land contamination and climate change, what we've got saying about it in our legislation, policy and guidance. So for land contamination, issues are addressed in the UK legislation either through Part 2 of the Environmental Protection Act or via the planning system. The key pieces of legislation associated with climate change are the Climate Change Act 2008 and the Climate Change Scotland Act 2009. And they established the Committee on Climate Change and require a UK climate change risk assessment, a CCRA, to be published every 5 years to assess the risks for the UK from the current and predicted impacts of climate change. The Act also includes a requirement for the devolved administrations to develop national strategic adaptation programmes to manage the effects of unavoidable climate change in response to the risk assessment, setting out actions over 5 years. And then the adaptation programme places requirements on the planning regime to incorporate the effects of climate change within their decision making. And reference to climate change, you can find that within all the devolved nations planning policy documents. So in terms of the guidance that we have as land contamination practitioners, the need to include for potential climate change effects is outlined within LCRM, GPLC2 and BS 21365. It basically says that climate change is something that you need to consider. However, there is an absence of detailed guidance on how climate change should be considered in the risk assessments we complete. And that's partly because regulators are still developing their own policy in this area. However, this isn't just something that's been thought about. It's probably becoming a lot more apparent just due to the news stories hitting the headlines. And I think we all feel that climate change effects are being more pronounced, well, certainly in the last few years. However, back in 2007, Clare published a bulletin considering the impact of climate change on land affected by contamination and brownfield regeneration. Within it, it was recognised that certain climate change scenarios would have significant impact on current and future land contamination and remediation systems, and proposed an adaptation strategy to address this. However, as far as I'm aware, there hasn't been any further updates or evidence to indicate that the adaptation strategy is commonly being put in place within the land contamination sector. Last year, Clare published the Good Practice for Risk Assessment for Coal Mine Gas Emissions, and this includes a really good chapter on how climate change should be included in these assessments. So there is some detailed guidance starting to come through, and I'd recommend reading that document for anyone that hasn't already done so. It's a very good, kind of well-written document. But there is a lot of research and development currently underway, so you can expect a lot more guidance to follow. SOBRA is currently looking at how climate change should be incorporated into controlled water risk assessments, and we issued a draft copy of the guidance to the exec committee this week for them to review, so this should be coming out shortly. The EA has also commissioned a couple of projects to inform regulatory considerations of climate change impacts in relation to broader land contamination and remediation. That's through collaboration with WSP and Syria. Syria are also looking at developing a good practice guide for managing changing climate and contaminated land projects, and they've also got an interest group in this project on that topic. There's also a number of conferences coming up where climate change and sustainability are high on the agenda. So there's a SOBRA Summer Workshop happening later this month. Also, the Geological Society Contaminated Land Group will be hosting a 2-day event later in the year on this. So you can expect to see a lot more guidance and information coming on this topic. But I always think it's better to be ahead of the curve. So that's why partly I'm doing this presentation, is just to sort of understand what considerations we need to have within our CSM when considering climate change. So this slide is basically just showing a site, a potential typical proposed development site, where we've got a land contamination source comprising May ground, underlined by permeable river terrace deposits, and these are separated from the bedrock by till. The bedrock is coal measure strata with underground mine workings and a mine shaft. And the various pathways by which you might expect the receptors to be affected. We've got human health, could be affected by direct contact, inhalation of dusts and vapours. For the water environment, you could get leaching and entry into groundwater, followed by groundwater flow off-site to identified receptors, such as the stream that's shown in the picture. You could also get potential for overland flow as well. And ground gas, you could get desorption of gas from coal and rocks and migration of mine gas via preferential pathways. Within the CSM, I'm assuming that there's a good thickness of low permeability till overlying the bedrock that would limit migration via permeable ground. I'm also using mine gas as part of this illustration to illustrate concepts of ground gas. But a lot of what I'm going to talk about could be, applicable to ground gas that may be associated with, May ground sources. So the next few slides will consider changes that may occur to the CSM as a result of climate change. So this slide shows changes to the CSM that may result due to extreme high intensity rainfall events and also more long-term effects as a result of increased average annual rainfall. So what does this mean for human health? So for human health, it could include, there could be erosion of the source zone or slumping of the ground, or potentially even landslips that may lead to exposure of previously kind of contaminants that were previously contained at depth or not exposed. You could get pluvial or groundwater flooding, and that may lead to contaminant mobilization and bringing potentially contaminants up from depth towards the surface. Conversely, you could also get an increase in soil saturation, which would actually look to reduce potential for dust generation and vapour pathways. So for water environment, basically increased rainfall will result in increased recharge and leaching of contaminants. You could also get rising groundwater level, which could lead to a reduction in the unsaturated zone thickness or direct discharge. Also within the aquifer, you could get increased dilution and volumetric flow rate. Due to increased rainfall, you may find that you're getting needing to consider drainage being put in to manage it. So you could get formation of new pathways. Again, at surface, you could get erosion and immobilization of the source zone. There's an increased potential for overland flow. You could get flooding associated with surface water features, which could reduce your pathway length. Also, if you've got rising groundwater levels, you could find that you've got changes to or formation of groundwater dependent terrestrial ecosystem assemblages, which is shown here. Okay, in terms of ground gas, basically rising groundwater levels, you could see that gas actually initially is pushed out of the ground. So there could be an initial increase in gas emissions that you observe. If water levels rise so high that you end up with flooded mine workings and shafts, then that will look to stop desorption and limit the transport of gases. And also you can have fallen barometric pressure, which can cause expansion of gas and also an increase in emissions and flow. So those are things to consider for rainfall events. And this next slide looks at the converse. So this is looking at examples of changes to the CSM as a result of extreme heat events and average air temperatures increasing. Note that drought corresponds to a prolonged period of dry weather, and it's not necessarily always associated with extreme heat, but for the purpose of the slides, I've included them together. So again, for human health, we're going to look at that first. Because of extreme heat, you could find that you've got vegetation dieback, exposing soil with increased dust generation. You could find that there's an increased potential for volatilization and vapor inhalation. Wildfires could increase, particularly if you've got a derelict site with a lot of kind of vegetation, overgrown vegetation about. You could get wildfires resulting in particulate clouds and associated inhalation. Also, just the fact it's much nicer weather, drier, people are likely to be outdoor more, so you could get an increase in exposure time. For the water environment, you'll have a reduction in rainfall and increased evaporation, and that could result in reduced leaching, and also falling groundwater levels, so your unsaturated zone thickness could increase. Within the aquifer, though, you'll find that you'll get reduced dilution and reduced volumetric flow rate. Because of the hotter, drier weather, you might find that there's an increased demand for water, so you might find new water supply boreholes being installed, so you've got introduction of new receptors. Also within rivers, you could find that there's a reduced river flow, and as such you may find that there's increased reliance on baseload to sustain surface water receptors. You could also find that you could get erosion of riverbanks and alteration of channels, which could potentially, again, lead to a change in pathway length. And for ground gas, falling water levels could result in formation of void space and desorption of mine gas. Or you could get potentially an increased atmospheric pressure, reducing or potentially even reversing gas flow. Another thing you could get with hotter, drier weather and cohesive soils in particular is the formation of desiccation cracks. So this is highly exaggerated, I do appreciate it, but it's just to sort of show a point that formation of desiccation cracks, it could create pathways. So before I said the till was low permeability, quite a thick, good quality, low permeability soil, stopping migration from bedrock. But if you get formation of desiccation cracks, then potentially you could be opening up a pathway for emissions there. So that's the CSM considerations for drought and increased temperature. Also, I should point out what I was going through in the previous slides. They're by no means exhaustive, and there could be more that could be added within that. So also as a consequence of global warming and average air temperatures rising, you could find that there's a corresponding increase in the temperature of the ground in shallow groundwater and surface water. So that may impact phys-chem properties, such as you could see there's changes in solubility, dissolved oxygen levels, changes in the volatility of contaminants, changes in NAPL viscosity. You may find that that NAPL moves a bit more freely in the subsurface. You could get changes in microbial activity, so bugs could become more active, and also changes in reaction kinetics. However, soil thermodynamics are highly complex and they're influenced by many factors such as soil composition, moisture content, and ground cover, and they can vary greatly between seasons as well as over a short distance and depth within the soil profile. Also, another point to note is that atmospheric average air temperatures are projected to increase by a maximum of 4.3 degrees. So those temperature changes are relatively small when you compare them with the variation in temperatures for which literature sources provide for physicochemical properties that we use in subsurface modelling. So what does this mean for our site investigation design? So initially, we want to know where the site is located and is it actually sensitive to climate change effects. So whereabout geographically in the UK is it located? As part of your sort of site reconnaissance and walkover, you can look at things like the surface cover. Is there any areas of unstable ground, potentially areas for flooding? It's going to be really important to delineate your source, both laterally and vertically. Understand if you've got any preferential flow pathways, such as subsurface infrastructure, either currently on site or potentially proposed as part of redevelopment. Have you got any shallow mine workings underlying the site that could be affected by climate change? Other things to think about would be, is your site hydraulically connected with surface water? And looking at variation in groundwater level, both seasonally and tidally. And also making sure that you're capturing falling atmospheric pressures and recording gas concentration and flows. So it kind of comes down to your monitoring program and making sure you're developing something robust. But essentially, good site characterization and conceptualization is key. So it's not talking about anything new here. We should all be designing good quality investigations and really kind of looking at the conceptual site model and designing around that. And also kind of need to consider climate change at PRA stage to enable a robust site investigation design to be delivered. Okay, so just to round up, hopefully been able to kind of go over that climate change science is complicated and it's continually evolving and constantly changing. There's also a lot of work being completed on the topic of land contamination and climate change, so guidance is likely to change in the future. There's regional variability across the UK with respect to how climate change is being realised. So climate change effects need to be considered at a site-specific level. There's not a one-size-fits-all approach that can be developed. Climate change can be associated with chronic long-duration processes, such, for example, risk to groundwater from ongoing leaching as a result of groundwater levels rising due to an increased average annual rainfall, or they can be acute, more rapid events, for example, erosion of source area due to intense rainfall or drought. And both acute and chronic climate change effects should be considered within the CSM. Climate change effects may fundamentally change the pollutant linkages being considered within the CSM, in particular source contaminant behaviour, active pathways and the proximity to and type of receptor being considered. Good site characterisation and conceptualisation is essential and it needs to be considered at the outset from PRA stage. It shouldn't just be an afterthought. And what really needs to be done is that you incorporate climate change projections and explore consequences within a risk assessment. So next I'll be happy to take any questions that you have, but just leaves me to say thank you for listening to me.
Thank you. Thank you very much, Helen. We have a couple of questions that have come in and we'll see if any more come in. First off, is there any international guidance available on this subject?
Yeah, there is. So basically, America and Australia seem to be have published a few guidance documents already on this. If you Google things like climate resilience or adaptation, it sort of takes you to a few different things. Their ASTM and ITRC have both published kind of guides looking at climate change and how that could potentially be incorporated within land contamination risk assessments right through to remediation. Basically, both are highlighting, conceptual site model is key, and that should be updated and iterated as you get more and more data. Also, there's in Australia, there's a National Climate Change Adaptation Research Facility, and again, they've published some documents there as well about how climate change could be considered. So just a point to note with international guidance is that they are for different climates than is in the UK. Yeah. We're quite a temperate climate. whereas just due to this vast size of America and Australia, they cover a much broader spectrum of climates. But still, the key principles are that conceptual site model is key and essential, and once you understand that, you can then look to build your climate change projections within that.
Okay. Are there any additional climate change considerations you'd need to include if you have a site located near the coast?
Yeah, that's a good point. I think I covered that in the first slide, but maybe didn't really cover that in the CSMs that I went through. So yeah, there are different things to be considered. So you've got changes in sea level. You could think about coastal erosion. There could also be an influence on the tidal limit that could maybe move further upstream. You could see an influence on hydraulic gradients. They maybe become a bit more shallower as sea level rises. You could get potential for coastal inundation and flooding. Yeah, so there is more things to think about. Also saline intrusion as well, so that your kind of lens underneath the site may expand. So there are a few other things to think about.
Okay. We have another one in. What kind of new data sets can help with the conceptual site model?
New data sets. So I think I went over the majority of data sets that there are available in the UK for projecting climate change. So we've got the UK CP18 data set. But one I think I quite like, particularly for water environment related focus, is the eFlag portal that was recently launched. And that includes information on recharge. So it basically projects what recharge there is for basically different groundwater bodies across the UK. And really, when we're looking at risk assessments, a groundwater body is kind of better to look at than a geographical kind of arbitrary boundary for a local authority. So there's that's a really good data set to look at, and that's got recharge information, which again is what we're more interested in for the risk assessments that we complete. And it's also got some information on changes in changes in groundwater levels. Although the flag, it is just for bedrock kind of groundwater, not the more kind of surface superficial aquifers that will probably be more susceptible to climate change variation. So that's just a bit of point to note on that. But the flag portal is really quite useful, I think.
Okay, right. Well, that's all we've had in. You'll be pleased to know. So I'm sure everyone. Oh no, sorry, I shouldn't have said that. Just have one more in. Given that climate projections themselves contain a level of uncertainty, how do we carry out an appropriate cost benefit or sustainability assessment taking this uncertainty into account?
Oh, that's another good question. The projections, they do have uncertainty built within them. As I said, RCP 8.5 is the data set that appears most comprehensive, and that one is based on worst case kind of climate change effects. I mean, they were developed primarily for looking at water resource management and flooding. So I guess you want to make sure you're well protected, and those things are well protected when you're doing your risks for those. Potentially land contamination doesn't warrant such a pessimistic assumption. But I guess that's for policymakers and regulators to decide which scenarios looked at. I think it just goes back to your CSM again, having a look at the data, where your site's located. There may be some sites that climate change is only going to have a negligible effect, but it's sort of those that are, maybe in the southeast of England where there is kind of greater rainfall projected, or you've got coastal sites where sea level rise is, potentially going to cause implications. I think it really is just sort of having a look at your site, where it's located, and going through your CSM, gathering as much data as you can. So for example, if climate change is something that could affect your site, making sure you've got a robust data set for monitoring. For example, looking at continuous monitoring in boreholes for groundwater levels. So if there was a period of intense rainfall, you can see how the aquifer responds to it. Is it very flashy, or does it kind of buffer the change? So it's sort of looking at the data that way and trying to understand your aquifer system and your site. So it's really just characterizing and conceptualizing your site and using that data to then build upon your risk assessment. Yeah.
Okay. Is there a chance that the movement away from carbon use could lessen business opportunity in the CSM industry? I'm not sure, quite sure what the question is saying there. But is it good? Yeah.
So I don't think so. I mean, ultimately,
No,
if there's going to be a reduction in carbon, it's kind of making sure your assessments are being undertaken more sustainably and sort of using local resource rather than sending someone halfway across the country if you've got a local office to do things. There's other things that can be thought about in terms of the investigations we do in terms of making them more sustainable, or if there's added value that you could include, such as looking at soil health. Because soil is a great carbon sink, and you're kind of wanting to make sure you're kind of using that. So there's a lot of other things you could think about in terms of soil health and how you could potentially add value to the investigations that we complete. So I'm not sure if that answers the question, but
yeah, possibly. Do we know if increasing salinity and other climate change factors have been taken into account for WAC testing or waste acceptance to coastal landfills?
I don't know the answer to that.
Nor do I. I suspect not, because the WAC testing, the WAC values are the same wherever you are in the country.
Yeah, and I guess most landfills now aren't kind of very coastal where you'd probably see an increase in salinity. So I would say no, and also landfills are designed so that they're not actually going to, cause an impact to the water environment. So I would say probably not, but
fantastic. Well, thank you very much, Helen.
No problem.
For a great presentation. So it just leaves me to say thank you, everybody, for joining us this afternoon. Please join us again next month. We'll be having a presentation on PFAS contamination in the environment. Hopefully we'll get some information out to you all on that next week. So have a good afternoon, everybody.